Thanks for Professor Fei Wang's invitation. My name is Zhihan Liu. I'm currently working in Uppsala University in Sweden. The topic of my presentation is Metaverse. First of all, this is an evolution. The first step is 3D graphics. From 3D graphics, it's evolved into 3D visualization. When 3D visualization meets human-computer interaction, it's evolved into virtual reality. When virtual reality meets Internet of Things, it's evolved into digital twins. And finally, it's evolved from digital twins to metaverse. My background is mostly design and development of virtual reality system. So in my later presentation, most of my talk is about the design and the implementation of the virtual reality system, but not so many very deep theory and concepts. Here you can see the player wears the virtual reality glasses and attach some sensors on his body. He is in the reality in a room, but in his imagination, he's immersed in a virtual world. In the virtual world, he's a full power warrior, and he can even destroy the walls around him. Virtual reality has three features. The first and also the most important feature is immersive. And in these four pictures, you can see a player when he uh, plays a virtual reality game. It might be the first time for him to play the virtual reality game, and he's fully immersed in the game. When another person pushed him, he lost focus, and he's very fear, and then he's struggling, and some other persons come here to control him because he's totally immersed in the virtual reality game, and he's so fear. Human has five senses: sight, touch, hearing, smell. The most important feeling is the sight. In the left figure, you can see the player wears the virtual reality glasses and he's walking in the room. But in the virtual world, he's roaming in the virtual reality world. And in the right figure is another device. This is a virtual virtual racing. He's playing the virtual racing, and he is on the virtual car. Here in this virtual flight, the person is on the virtual flight, and here there is a fence blown to this person so that he can feel he is flying on the sky. This is another device. It's called omnidirectional treadmill. When the player walking on this omnidirectional treadmill, and he can also walking in the virtual world. This is HoloLens. It's a virtual reality glasses, and is also augmented reality glasses. When the player wears this HoloLens, and he can see augmented reality with the reality world, and he can also use the finger gesture to control the virtual objects. And here is the very classic device is called lip motion, and it can recognize the human's hand gesture. Here is a device so-called brainwave. The brainwave has some points. For example, in this device, it has 8 points. That means there are 8 channels. And from these 8 channels, the brainwave device can read the brainwave from the person. This is also an evolution of the contact lens. And at 2013, Google has product a smart contact lens. And at 2017, there is another product it called Triggerfish. On Triggerfish, it can detect the pressure of the blood. And you can see there are some sensors on this contact lens, the controller, capacitor, and the sensors. And at 2020, another module lens is born. Is born in Switzerland. This contact lens can not only detect the pressure of blood, it can also implement the augmented reality on the contact lens. Here you can see when the player wears this contact lens, so-called module lens, and he can see the reality world and also with the augmented virtual world. They mix that together. Another device is about the EMG recognition gestures. I think in future it can be integrated into the smartwatch. And even here you can see this EMG-based recognition gesture can also recognize very complex, very complicated gestures like the bow archery. And here is my previous work is hand gesture and foot gesture interaction, and they are touchless interaction. I attach this uh, mobile phone on the wrist and also on the knee, so that the rear camera of the mobile phone can detect the hand gesture as well as the foot gesture. This is the demonstration of the hand gesture interaction. This video is recorded at 2013. At that time, the mobile phone, the smartphone is not so fast. So you can see the video is a little bit lag. But today's mobile phone is very fast. So the recognition of touchless hand gesture interaction will be very fluent on today's smartphone. And further, I have integrated the hand touchless interaction on Google Glass, and also the foot touchless interaction on Google Glass. The virtual reality applications, you can see usually the virtual reality can be used in some traditional fields. For example, in the medicine and the healthcare, and also in the industry and the factory, and also used in the city and the building. The ideal applications for virtual reality should have some features. The first and also the most important is the very strongly visual and have 3D spatial elements. It can be implemented by the virtual reality glasses. That's also I'm saying the most important feature of virtual reality is immersive, and the most feeling of virtual reality is sight. The second feature is it benefits from the first person immersion. It also implemented by the virtual reality glasses. The third one is the benefit from the 3D manipulation and navigation. And this one can be implemented by the hand gesture interaction. as well as some other devices. Finally, it supports autonomy, interaction, and presence. The typical system is a very classical system. It can implement the wide area virtual reality system. It includes several devices. The first is a wide area tracking. It's based on computer vision, and there are some lights and reflective bars. And it has usually more than 120 cameras for 300 square meter space. So it's a very wide area. And for the player, they usually have a backpack VR system. It includes haptic feedback vest and wireless HMD. The HMD means head-mounted device. That means it's virtual reality glasses. And also about the environment, the real props. It includes tracked objects and walls. The demonstration of the typical system is the large-scale VR game. So far, there are two famous VR gaming. The large-scale VR gamings. The first one is the Void, and the second one is zero latency. You can see in the pictures, the players wear the HMD and hold the weapons in the very wide areas, and there are some walls and probes. And the players, they can shoot each other, and they can also shoot the monsters in the virtual world. Another case is Facebook Space. Facebook Space is a collaborative VR environment. It's a VR meeting and interaction space, but the limitation is that it's up to 4 people, so it's not a wide area virtual world. But it's focused on communication, so the players in these Facebook spaces can do some communications based on speech and gesture. And this is my previous work. This work can prove the virtual reality can be applied in geographics. Now here is a 3D map. We use the virtual reality to render the 3D map and import it into WebGIS. So this is a 3D WebGIS, and also we can export it into the mobile phone. And on mobile phone, the user can play with the 3D web mapper. And this is another version of the WebVRGIS. And it needs the plugin because we use Microsoft ActiveX to make it into plugin. And this is the 3D Global, 3D Terrain, 3D City, 3D Building, and even the 3D Seabed. Here are some other cases based on the 3D web mapper and also the WebVRGIS. For example, it can be used in industry and tourism, and it can render the big ship with the leaking oil, and also the sunshine analysis. And we also use 3D web mapper to implement virtual community. It can be also used in education. When a user wears the virtual reality glasses, and he can see the 3D seabed wear by the virtual reality glasses. And we also attach the remote sensing data on the 3D Global. And this is a demonstration about the 3D city.
With a 3D Earth model as the browser, this system is loaded with all 3D model data and the 3D visualization analysis results. At the same time, the top view-based position observation is conducted through a 2D Hawkeye map on the left. By selecting the house in query, it is possible to find out the information of the address and owner. This function is to achieve holographic data query for every household of the specific community respectively by building 3D virtual house and associate with relevant data. In addition, it is also possible to click the red airplane icon for positioning. At the same time, it is also possible to input the road name for road inquiry. The 3D building is to take inventory and display various types of object data management and resource data within the jurisdiction area. Community analysis function can have a comprehensive observation to the 3D model of a community and analyze, display various data. Community analysis function includes population age composition, education background composition, nationality composition, community marriage status, and employment status. These figures can be derived from macro to macro and zoom analysis layer by layer. These functions are the basis and core to analyze the city data. 3D roaming function can not only conduct the showing top view observation about the community, but also observe the detailed layout near the street. The birth of this platform can make full use of information technology to improve the city's comprehensive level of service management. To achieve shares of information resources of all departments and the dynamic tracking for the population, legal persons, and geospatial information. By constructing an integrated information platform of social services, which are the area of coverage, street, 4 level of network, and help the city community to grasp the work base by the supporting of holographic foundation library. In addition to the observation and above-ground model, it can also observe and manage the underground model and ground the city. This platform can also manage the urban traffic and real-time road condition. It can visualize the road condition in the form of line and plane. Besides the data from the database, it can also render the GIS vector data. In addition to real-time data, it can also load the historical data. This platform also manages the data in various stations and subway stations in Shenzhen and forecasts the passenger flow. The data contains the land and ocean, the ground and the underground, the outdoor and indoor, building and people, real-time and history, as well as the forecast. Finally, it counts the population distribution in various areas of the city. The 3D Shenzhen case proves WebVRGs is a useful tool for the social service agencies and citizens for browsing and analyzing city big data directly.
This video is recorded at 2015. So at that time, we need to use the plugin, the ActiveX, the plugin to integrate the 3D scene in the website. But now we have the HTML file. So now we don't need to integrate any plugin in the website. It will be more convenient. Next case is about the virtual reality molecular. I have done this work at 2010. These are some effect about the 3D molecular visualization. And we also implemented a shader, GPU shader, to render the bone and also the sphere of the molecular. It can be also used in rendering the network visualization here. And then we export this shader, the 3D molecular visualization on iPhone. These are some demonstrations, some results of the 3D molecular visualization. The first one is the secondary structure of a molecular. The second one is the electric fields visualization. And the fourth one is the physical engine visualization of the molecular. And the sixth one is the blood effect. The third one and the fifth one, they are the general molecular visualization. The next case is my previous work about the virtual rehabilitation. In the virtual rehabilitation, you can see these are three cases. In the first one is the voice rehabilitation. The player control avatar in the virtual world to avoid some barrier, and by this action, the patient can increase his pitch. And the second one is in the oxygen chamber. The patient is laying in the oxygen chamber, but it's too boring. So we ask the patient to wear the virtual reality glasses and enjoy the fun from the virtual reality games. And these two pictures is the balance calculation from the Kinect tool. From this body, from the Kinect, we calculate the gravity of the patient and further calculate the balance of the patient. And we compare the result from the Kinect-based balance calculation to the V-balance bar-based balance calculation. And the result looks similar. So, but the Kinect-based balance calculation is very cheap and very fast. These are some photos about the cases that the therapist assists the patients to do rehabilitations by playing the virtual reality games. So this scene is one kind of the example of the virtual rehabilitation. And this virtual reality game is for the cognitive rehabilitation, and all of others are for the physical rehabilitation. These are our previous works, some of my previous works. And actually, the virtual reality can be used in different fields. So let's define the virtual reality. The first is the feature of virtual reality. The most important feature of virtual reality is immersive. And the method is also called device. By some device, we can implement the virtual reality. The first and also the most important is VR glasses. The second one is omnidirectional treadmill. The third one is hand gesture, and some other devices such as brainwave device. And the virtual reality can be used in some different fields. That is called virtual reality content and also called applications. It can be used in medical, gaming, military, and education fields. First, and next, I will talk about some cases about the digital twins. They are all of my previous work. This is the digital twins of the factory, and you can see in the center is the 3D models of some devices, some equipments in the factories. But around the 3D models, there are some data the data can show the information, the status, the situation of the devices. This is the digital twins of the crossing in Shenzhen. It's the same UI. You can see in the center there are some 3D models of the cities, street, and the crossing. But around there are some UI to show the data, show the data, even show the real-time video of the crossing. And by this virtual reality by the digital twins of the crossing, it can monitor the crossing and also can control the sensors attached in the crossing. This is the digital twins of the this is the digital twins of the factory. It's the electric factory. We 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 still use the 3D model to visualize the factory, and we use some UI to show the data of the situation, the status of the device in the factory. This is a demonstration of the digital twins of the biogas engineering. By this kind of the digital twins factory, it can monitor the status of the equipment in the factory. It can also detect and check the some problems in the factories. Finally, this is the case uh, of the application of predictive control in the sewage treatment for large sewage treatment plant. So this is in this digital twins, it not only monitor and control, it can also prediction. It can also do prediction. You can see here in this pump, it can predict the problem of the device. And next I will talk about the building metaverse. So the metaverse, we can consider the metaverse is meta plus verse. The verse means universe. Actually, so far there are some software to visualize and simulate the universe. For example, the Wuchu and open space. The left figure is the Wuchu. You can see is simulate the universe, and the right one is the open space. Is visualize the universe. But now we want to define the metaverse as the narrow sense metaverse. So first, the metaverse includes different scales: micro scale, meso scale, and the macro scale. And it has also different states: the solid, liquid, and the gaseous, the plasma, and some uncertainty state. And it also has some social relationship. It includes friendship, love, blood, and ethics, morality, and the religion, and the law. In the multi-scale, you can see there are many different scales, from the subatoms and even the quantum dots to the molecular structure, to the cell structure, and the tissue structure, organ structure, to the human body structure. And from the indoor to building and to city, region, country, continent, and further to Sun-Earth system. the different state. The different state we have simulate some different states. For example, the digital tones of electric, and we also simulate the digital tones of magnetic field, the digital tones of fire, digital tones of liquid, the digital tones of wind. Here are some videos, and you can see at the first picture we use the Tesla to simulate the electric, and it can be controlled by the hammer. This is a visualization demo on the Nature at 2009. It's very old video, so it looks not very not very good. It from the hand scale to the cell scale, from hand scale to the cell scale, and then zooming in the cell scale space, and return to the hand scale. And this is my work. I visualize the macro scale space to the micro scale space. First from the global and to the city, and to the indoor, to the human, and to the organ, and, and then to the cells, and then to the quantum dots, and to the graphic particles, and finally to the accelerant. So in my demonstration, I have done more in the micro scale. This is my current work. I want to implement uh, more, more like Metaverse, because in the previous virtual virtual world and the virtual community, mostly is the 3D visualization and simulation. But now in Metaverse, the human and human interaction is more important. So I want to implement more and more human and human interaction in this work. Now let me introduce some functions in this video. Firstly, the players they can handshaking and hug. but in previous virtual world, they cannot do that. And secondly, all of the voice and the chatting are saved, are recorded in the blockchain, but it's a very new functions. And also the multiplayers, they can synchronized edit the scene together. Okay, thanks. That's all. Thanks for invitation from Professor Fei Wang again.